Promised, you already know how to do everything we're going to do today. I told you that I would finish this page yesterday, and it is the last part of your work from yesterday. It's all in one spot. This is the page that you're going to use to do the next 5 questions. Now, yesterday during class, I said we were going to be writing a quiz today. Yesterday during class, I didn't know we were doing a lockdown. So we're not going to be writing a quiz today. We'll have our quiz tomorrow. Right? But page 110 and what we're doing today is the stuff that's going to be on the quiz. Hokely dokley? Hokely dokley. So let's go to page 111 and let's have a look at this situation. Is your hand up or what do you need? There is XBlock this week. That's why there's names on the board, and that's why the announcements have said go sign up for XBlock for the past 3 days. Today is Wednesday. As you can see, I have 4 people signed up. If you walk by my room tomorrow at XBlock, will you see only 4 people in it? No, because we have these really complicated rules about how to get into an XBlock. Sign up somewhere. I don't know where I'm going. Right? So, of course, because there are no names from Block A up there, I will see none of you in my XBlock tomorrow, will I? Not one. Or you will put your name by the letter A, and then and only then will I see you in my XBlock tomorrow. Clear?
Are we here by default anyways?
Huh?
Are we here by default anyways? Because it's day 1 tomorrow?
Yes.
Do we still have to sign up?
Yes. Because sometimes I have other classes. I've been known to have 30 kids signed up in here before the default class stays. Because the default class was too lazy to get off their butts and sign up somewhere. Which means my entire default class stays, plus the 30 kids that actually wanted help. See what I mean? That's why we developed that cunningly difficult system of signing up and going somewhere. All the teachers sat down and said, how can we make it the most confusing as possible for the kids? I know, we'll ask them to sign up and go somewhere. Damn. They'll never figure that one out. All right. Here we have a parabola. I want you to tell me the equation of that parabola in standard form. Yes? Now, we have how many forms of the parabola with which we can work? 3. Factored form, standard form, and vertex form. Which of those 3 do I have information for here? Do I have a vertex? No, I do not. So is vertex form going to be my friend here? No, it is not. Do I have roots? So factored form is going to be my friend here, right? So, question I ask myself, vertex or roots? I have roots, so I'm going to use the factored form right now. Yeah? So, the factored form of this parabola is y equals a x minus p, x minus q. Yes? Okay, so what is it? Why? Do we know the a? We don't know the a because we don't know the vertex. We don't know the stretch, do we? So a has to stay alone. X, what is that root? -2. So how do I write it in the form? +2. Well done. Then, what is that one? 4. So how do I write it in the equation? -4. Brilliant! Everybody cool? Now, how many unknowns do I have here? I have 3 unknowns, right? X, Y, and A. What do I have there? I have X and Y. Do I have 3 unknowns here? Yes. Can I fill them with anything that I know from my graph? Yes, I can fill them with an X and a Y. So I get not y, I get negative 16 equals a, not x, 0 plus 2, and not x, 0 minus 4. Negative 16 equals a, 2 minus 4, yes? Okay. Negative 16 equals negative 8a. A equals what? 2. So now I have y equals 2, x plus 2, x minus 4. Am I done? No, because I want what? So what must I do? I gotta FOIL this out and then distribute the 2. Right? I can FOIL that out in my head because it's in that form. It is x squared. 2 minus 4 is minus 2x. 4 times 2 is negative 8. Then I distribute 2x squared minus 4x minus 16. And I'm done. How do I know I'm done? Isn't C the y-intercept? Is C the y-intercept? So I'm all good. Everybody cool? How do we do it? Choose the form, put in the x's and y's that we know, or put in the vertex that we know, or whatever, and find the missing letter. Ease bees lemon squeezy, right? Are you ready to try it on your own? I hope so, because I only have like 8 questions. So if I do one more, then I've done a big chunk of your work. Let's just see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I have 10 questions. So I'm willing to do one more if you want to see one more. Yeah? Okay. Yo. Yeah, cool. It'll all be on the video.
All right, thank you.
See you later, buddy. Bye. Okay. So the question I ask myself, what's the question? Vertex or roots? What do I have? I have a vertex. So what form should I use? So I better use vertex form, which is y equals a bracket x minus p bracket squared plus q, yeah? P is the x, q is the y. So let's fill this in. What do I know? Y equals a x minus 6 squared plus 3. Yeah? Everyone agree? How many unknowns do I have there? I have 3 unknowns right now. Now look at the graph. What do I have right there? Oh, that's a horrible color to use. And now it won't erase. What do I have right there? An x and a y. Where do those numbers go? Here's where you're going to make your mistake. This x and y was p and q. This x and y is x and y. Everybody cool? So what am I going to write here instead? Negative 15 equals a bracket 0 minus 6 squared plus 3. Negative 15 equals, what's negative 0 minus 6 squared? 36a plus 3, yes? Minus 3 minus 3, negative 18 equals 36. A equals? Nope.
Whoa, what?
1/2.
1/2. So
Negative 1/2. So now I have y equals negative 1/2 x minus 6 squared plus 3, correct? Is that the form I want? Nope. So negative 1/2 x squared minus 12x plus 36 plus 3. Yeah? Negative 1/2 x squared plus 6x minus 18 plus 3. negative 1/2 x squared plus 6x minus 15. Is that standard form? Is minus 15 the y-intercept? When I went 6 that way, I should have gone down 36, yes? But I went down 18. 3 to negative 15 is 18. My a is 1/2, so the 36 has been cut in half. My a is negative, so my parabola is sad. Aww. Okay. Okay. Now, because you guys wanted to see one more, the first thing you're going to try on your own is the almost impossible one. And then we'll finish up. Mr. Myers, I'm this close, man. Can you just do one more? No. All right. But listen, please. All of you except... No, because he would have learned it in grade 3. And Sarah, I don't know, I'm not aware of the German math machine. David, you had a grade 10 teacher in Canada. But it wasn't me. Yeah. Jorit, Karn, and David might be in a little bit of trouble. The rest of you is, and Isabel maybe. The rest of you is, I don't know, Brazil? I don't know. The rest of you is know how to do number 3. Okay, I'm going to give you a hint. Because I care. Why is that difficult to solve? Because there's 2 variables. Do you have a method to fix that? Yes, as a matter of fact, you have 3 methods to fix that. You could fix it with graphing, which would be a stupid method to use. Or you could fix it with, starts with an S, ends with an N, has substitutia in the middle. Or starts with an E, ends with an N, and has eliminatio in the middle of it. Elimination. Now, ladies and gentle people, real easy when there's 2 unknowns, right? Okay. What's different in grade 11? It's ax squared plus bx plus c, isn't it? So there's 3 unknowns. So it would be like this. And then 4x minus 3y plus 6z equal 24. Now, again, I will remind you, what is the purpose of substitution or elimination? What does it do? It gets rid of one of the variables so you can substitute back in, right? Well, if I subtracted these 2, will x disappear? X minus x will disappear x, won't it? So if I can isolate one variable, I can work my way backwards. Everybody cool? All right. Attempt number 3, possibly crash and burn, but then you will have no problem with number 1, 2, 3, 4, or 6. But you might have a problem with number 5. 7 and 8 are no problem. You've got a vertex for both. The third example and the fifth example are difficult. Oh, now I feel bad. Oh, let's do this one together. Stop it, you guys. So nice to you. Okay. All right. Let's do this one together. No, I'm going to do this one. I'm stopping here. Yes. 100%. Gavels down. I'm stopping after this one. Shut up, Rhea. Fine, go. There you go. No. Rhea doesn't. No. Rhea says I should stop. Oh, okay. Sure. All right. Everyone agrees, yes? That's what it's going to look like, right? Our final answer is going to be in that form, correct? Yes. Okay. Now, unknown, right? But are they? What's that? There's an X and a Y. So that would give me 4A plus, sorry. Minus 8B plus C would equal 9. Does everyone understand why? X is negative 2. What is X squared? 4A. X is negative 2. What's 4 times negative 2? Oh, sorry, that should be a 4. 4B. It is negative 2B. Jeez Louise. Now we're good? Okay. Now I'm going to change color. What's this one going to be? $16A plus 4B plus C equals 3. And lastly, what's this one going to be? 4A minus 7B plus 2B equals what? Negative 7. Now, I have many unknowns, yes? What can I eliminate right now? I could eliminate C because I could subtract right there. Could I eliminate A? 4 and 4. Could I eliminate B? Negative 2 and 2. So who makes the decision? You do. Does it matter which one? Okay. Now there's a third way to do this, but I want to keep with grade 10 right now. I would say let's get rid of, we're going to number them 1, 2, and 3. Let's do 1 plus 3. Everyone agree? So what is 4A plus 4A? 8A. Negative 2 plus 2? Gone. 8A plus 2C equals what? 9 plus negative 7 equals 2. Everybody cool? Okay. Now, 2C equals negative 8A plus 2, yes? Everyone still okay? So C equals negative 4A plus what? 1. If C equals that, What can go in for all these C's? Negative 4a plus 1. Is everybody cool? Now, once we know C, once we've eliminated the C's, we've got now A, and B, right? So we can put that in, collect our like terms, and then we're going to eliminate another one. Is everybody cool? So what can I write now? We didn't use this one, did we? The green one? So let's use that one now. The green one will now become 16a plus 4b plus what? Negative 4a plus 1. And what will that equal? 3. Solve this. 12a plus 4b plus 1 equals 3. Yes? We all okay? 12a plus 4b equals 2. Is everybody cool? Okay. Now, does it matter which other one we work with? Does it matter which one we work with? We're trying to eliminate A or B, right? So could we use either one of them? Do they both have A's and B's in them? Sure. Which one do you want to work with? Choose a color. Pink? Great. So pink is going to be 4a plus 2b plus negative 4a plus 1 equals negative 7, yes? Which is 4a minus 4a. Hey, wait a minute. What just happened? The a's are gone. 2b plus 1 equals negative 7, yes? 2b equals what? Negative 8. What does b equal? Negative 4. So what can I do with that now? I can plug that in where? Anywhere. I've already eliminated C. B can go in there. Can I find A? Anywhere I put it, yes? So choose one to work with and do it a third time. Is everybody cool? Oh, you sure you did this in physics? You absolutely did this in physics.
Gotta pay attention.
It probably doesn't sit in the front row. Or do you?
Yeah, he was pretty close.
Is that in the second row? Well, that's one row away from the first row. So maybe he only pays attentio, not attention. See what I did there? Took off the N. Yeah. All right, are we cool?
We hear the guys in the back say, "Oh, what are we doing?"
Yeah, I know. Yeah. Where'd Van Damme sit in physics?
I don't know.
Are we all okay? Now, do we need to finish it off? Let's finish it off. So I got my B, right? Now all I need is an A, correct? Right? What do I see right there? See you. I just need an A, don't I? So what can I put in for that B? So 12A minus 16 equals what? 2. So 12a equals 18. So a equals 18 over 12, which is 3 halves, right? So now I've got a equals 3 halves. B equals negative 4. What's the only thing left that I need? C. Do you see a C isolated anywhere in my work? Top right. What's A? 3 halves. Negative 4 times 3 halves plus 1. What's negative 4 times 3? Negative 12 divided by 2. Negative 6. Negative 6 plus 1. Negative 5. What's C? Can I solve this now? Y equals ax squared. What's a? 3 over 2 x squared. Plus bx. What's b? Negative 4x. Plus c. What's c? Negative 5. Now, does that make sense? Let's check. Is our y-intercept negative 5? Or is it? Does that look negative 5e? Okay, that's one check you can make. What's the other check you could do? What letters do all these represent? X's and Y's. Put any one of them in here. If it works, we're right. Does everybody understand? How many times have I said it? If you've learned it in math, it's coming in grade 11, right? We learned systems in math. Is this grade 11? So systems are coming. Everybody with me? Everything you learned in grade 11 is going to do what in grade 12? Come back again. Along with grade 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, kindergarten. When you get to calculus, is grade 12 going to come in? Is grade 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, kindergarten? Yeah. Okay. Hey, Riley, how many times have I been able to say, you have 3 apples, and Harkirat has 3 apples? How many apples do you have? That's kindergarten math. How often do I have to say it again in grade 10? A lot. So, it all counts. Right? Right, Harkirat? Yeah. Is everybody cool? Now I'll give you a big hint. Why did I have to go to systems there? Did I have a vertex? No. Did I have roots? No. So you got to have a tool for when you don't have the stuff. Now I'm going to give you a big hint because I love you like my own. Does number 5 have a vertex? No, I'm not going to do this one. Does number 5 have roots? No, so what are you going to need to use? Systems. But it's a lot easier because you have something there, but I'm not going to tell you what it is or Ria's going to make fun of me.